Welcome students to the series of lecture on fixed income, and in today's lecture we are going to discuss one of the most important concept in the entire fixed income curriculum, the price yield relationship. The price of the bond and the market interest rate or yield relationship. Now why this topic is so important? Because whether you're preparing for CFA, FRM or any financial domain examination, or if you're sitting for interview, and this is the question that every exam will test you. Every interviewer will test you. That is, what happens to the bond price when the interest rate changes? Not in this straightforward way. They will ask it in a very complex way that what is the relationship of price of the bond and interest rate in the market? And I know that everyone has some intuition about this relationship if you have seen all the lectures of the valuation session 1, 2, 3, and 4. We all know that bond price and interest rate are connected somehow. But the real question that we have to start asking now is the relationship direct or inverse? If the interest rate increases, do bond prices also increases or do they move in opposite direction? And most importantly, is this relationship linear or is it non-linear? That is exactly what we are going to understand in this lecture. Now, if I have to summarize the entire lecture in just 30 seconds, then I would say that bond price and interest rate have an inverse relationship, not direct, inverse relationship, but not just inverse. They have inverse, they have inverse convex relationship. What does that mean? It means when the interest rate in the market rises, bond prices falls. When the interest rate falls in the market, bond prices rises. But the movement is not in a straight line. The movement, the relationship is curved. So by end of the session, you will understand that price of the bond and interest rate, if you plot, it has a convex relationship. That is what we are going to understand in this session. With that, let's get started and deep dive into why price of the bond and interest rate have a convex inverse relationship. Cool. Till now, if you have watched all the session of valuation, if not, then please watch all the session of valuation session 1, 2, 3, and 4. In all the session, you might have seen that the value of the bond or the present value of the bond is equal to cash inflow, that is the coupon, upon 1 plus interest rate raised to the power 1 plus cash inflow 2 or coupon 2, 1 plus interest rate raised to the power 2 plus cash inflow 3 upon 1 plus interest rate raised to the power 3. If I summarize it, I can write the price or the value of the bond is equal to summation of cash inflows, summation of all the cash inflow from 1 to n, which is discounted by the interest rate. This t goes from 1 to n, this t goes from 1 to n, and you have to do the summation. So you can mathematically see that price and interest rate have inverse relationship. In the left hand side, price is in the numerator, and in the right hand side, the price is in denominator. So it has an inverse relationship. It is not like price and interest rate has a direct relationship. No, it has an inverse relationship. So we have seen it mathematically, we have intuition about this, but let's prove it numerically. And to prove it numerically, what you need to do? You need to do valuation of different bonds at different interest rate. So what I took three bonds, or you can say I took same identical bond. This is bond one, this is bond one, this is bond one. I have changed nothing in the bond. What I'm changing is interest rate in the market. What I'm changing is the interest rate in the market. Okay, if I start with example 2 or scenario 2, look into scenario 2. Face value is 1000, coupon is 6%, frequency is annual, maturity is 3 year. Interest rate is also equal to coupon, that is 6% effective annual. What should be the value of the bond? Do I need to use BA2 plus calculator or any calculation to find the value of the bond? No, it is going to be equal to the face value. Why? Because coupon and interest rate are identical. If you haven't watched the last session, valuation of fixed income, session 4, then you need to watch this session to understand this. So the value of the bond is 1000. Now, if interest rate falls to 5%, what will happen to the value of the bond? See, coupon is what? 6%. How the investor will perceive this bond? Investor will perceive this bond as a good investment because in the market, the interest rate is only 5%, but this bond is giving you what? 6%. So value of the bond is definitely going to be higher than 1000. Okay. And I think I just calculated it. It is 1027. But let's recalculate. Second clear work, second clear TVM. 1000 FV PMT is 60, N is 3, 5 is I by Y, compute PV. 1027. 1027. This is the price of the bond. Example 3. Face value 1000, coupon 6%, frequency, annual maturity 3 year, I by Y 7%. Interest rate in market is higher than the coupon. Interest rate in the market is higher than the coupon. Investor will perceive it as a bad bond. Investor will perceive it as a bad investment, and therefore the value of the bond is going to be less than the face value, which is 1000. So in the BA2 Plus calculator, I'm going to change what? I by Y. So see, I will change I by Y 7, I by Y, compute PV 973.75. 973.75. 973.75. This is the value of the bond. Now, if I have to ask you that whether price and yield or price and interest rate will have this image or this image, is it going to be increasing with interest rate increasing, as in graph A is if interest rate rises, then bond price will also rise. Or it will have an image that if it interest rate is rising, then the bond price is actually falling. If you see from this example, if interest rate is rising, bond price is falling from 1027 to 1000 to 973.75. It is actually falling. So definitely we cannot opt for graph A. We cannot opt for graph A because that is a direct relationship between price and interest rate. If interest rate rises, bond price will rise. We are not observing it. We are observing just opposite. That if interest rate rises, bond prices will fall. But the question is it going to be linear? This is a straight line. This is a straight line. Is it going to be linear? The answer is no, because if you see this equation, you see the power of 2 and you see the power of 3. Then some of the student who are not pretty good with mathematics will say that we cannot understand that, and I can agree for that because I do not expect you to do differentiation and do calculate double derivative to find whether it is going to be linear or not. So what is the way to understand whether it is linear or not? What is the numerical way to understand, okay, it is inverse, agree, but it is going to be linear or convex or concave? So for that, let's see. So till now we have concluded that it is going to have a inverse graph. But what kind of inverse graph? That's the question. Is it going to be convex? Is it going to be concave? So for that, let's use the same example. When the interest rate was 6%, the value of the bond was 1000. When the interest rate was 5%, the value of the bond is 1027. When the interest of the bond is 7%, then the value of the bond is 973.75. If we plot it, is it going to be concave or is it going to be convex or is it going to be linear? Let's see that. So for the time being, let's use this graph. Currently, if the interest rate in the market is 6%, then the value of the bond is what? 1000. Perfect. If there is 1% fall, 1% fall, the bond price will be here, and the bond price will be 1027. What? Bond price is 1027. And if you really want to know the exact value, let's calculate the exact value. 5 I by Y compute PV 1027.23. 1027.23. This is the new value of the bond. However, if interest rate increases by 1%, here the fall is of 1%, here the increase of interest rate of 1%, then the new value of the bond is 973.75. 973.75. 973.75. Let's calculate the difference, or the calculate the fall in the bond price from 1000. So 1000 minus 973.75. 1000 minus 973.75. This is 26.25. This is 26.25. What about rise? The rise is not 26.25. The rise is slightly higher. It is 27.23. Please understand. Please understand. If interest rate is falling by 1%, the rise is of 27.23. However, if interest rate is rising exactly by 1%, the fall is of 26.25. The rise is greater than fall. The rise is greater than fall. It is not equal. It is not 26.25 here and 26.25 here. The rise is greater than fall. It has to be non-linear. It has to be non-linear. And if you try to connect all the dots, it is going to be convex. It is going to be convex. And we will see in a Jupyter Notebook Python code where we'll try to plot the value of the bond for all the different interest rate, not 1% to 10%, 1% to 30%. And we'll try to find out whether we are getting a linear curve, a convex curve like this, or a concave curve, not just for three interest rate, all the interest rate. And then we'll conclude that yes, it is going to be a convex graph. Okay, so let's jump into our Python notebook and try to find out whether it is going to be a convex one or not. So this is our Python Jupyter Notebook. And see, you don't have to worry about that I have to learn Python or Jupyter Notebook usage to understand the value of the bond. No, you can actually find these value in a simple Excel sheet. That is up to you, or you can find different value with the help of BA2 Plus Calculator. What is the value for 1%? What is the value for 2%? What is the value for 3%? So and so forth in your BA2 Plus Calculator by changing the interest rate I by Y. And you can plot all the prices for different interest rate. You will see the curve. That is what I'm doing on this Python Jupyter Notebook. So see, face value is 1000, coupon is 6%, maturity is 3 year, frequency of the coupon is annual, that's why 1. And I'm saying that, okay, interest rate, first let's plot for interest rate 1 to 9%. And when you plot it, actually will not be able to see that curvature. Yes, there is a curvature, but that curvature would be very, very sleek. It would be a very simple or very nuanced curvature. Let's see. See, this is not linear. This is not linear. This is convex. And you will understand this if I say that please increase the interest rate not from 1 to 9%, but 1 to 50%. And let's plot it. See, now you can understand the curvature. Even for 3 points, it is not linear because the rise in the bond price for the same interest rate is always going to be higher than the fall for the same interest rate change. We saw we saw that when we plotted for 6%, for 6%, the value of the bond came as 1000. But for 5%, it was 1027.23. The rise was of 27.23 and the fall was of 26 something. Definitely it is lesser than 27.23. So rise is always greater than the fall. And I'm going back to my notes, but with one question. And think about this question. As an investor, as an investor, do you like this convexity of the bond? This is the convex curve or the convex nature of the price and the interest rate curve or price yield relationship. We call it as convexity. So, as an investor, will you love convexity or hate convexity? Think about it. Think about it.